Welcome. Let us talk about method overriding. Now, this is a very important concept when you have inheritance in place. That means you have parent and child, and one of the behavior of the parent you want to change in the child. So we actually get into the concept called method overriding. So Java supports method overriding. And method overriding means replacing the implementation of the inherited method with another implementation. That means you have a method in the parent and you want to change that in the child, and we do this by overriding. That means in method overriding, your method signature must be same, but the action items are different. And take a look at further that to override a method, we simply redefine the method in the subclass. An example you see here. We have a circle class and we have a private property here. But as you know, most of the time, parent class, we make this property actually protected so that child gets it. But now we consider this is a private property. We have a parameter constructor, and then we have a gate area method. So what I'm doing, this is public double gate area. That is the method signature. I'm now creating a subclass of circle. Class point extends circle. Point is a subclass. I have two private property of point, and this is actually a constructor because how many property should point have? Point actually has three property. What you see is xy, but I pass the super means I'm calling the constructor of the superclass circle and pass 0 there. And then I'm actually overriding this method, get area. Get area is a method which is actually already you have it in the parent, but now you are redefining this method and do something else. Alright, so this you return the 0, and then so method overriding happens to be when you create an application, you create a circle object and you create a point object and you call the get area method, but you get two different output because area of the circle, the first one is the circle.getArea, and pt.getArea is a child. You understand, point actually is a circle, and that's actually the area is 0 because it's a point. You have a very smallest area. So method overriding, if you consider the following inheritance hierarchy, what you see is class A, that is a parent. You have a do this method. You have class C from class A. C is a child of A. D is a child of A. C also has do this method. And then you have class E is a child of C and also do this method. So what happens in this entire hierarchy, we see that we have B is a child of F, F is a child of C. So what we create a D object, and then we create a E object. You see E object, and then we create a B object, and then I can call do this method. If I call do this method of E object, you can see E object do this method is the method, this method. That means what you are doing inside E object. But if you call do this method of D object, you are actually calling the parent method, do this. And then if you call the do this method of B object, you are calling the do this method of the C object. So you can understand that how this method overriding works, right? And then you can see here, this is very straightforward, right? Yeah, see, as I told you, yeah, see. So when you are calling the do this method of B object, it's automatically pointing to this particular child because do this is written here. Alright, so the super keyword again, consider you can call the method of the superclass. So suppose you have a private height and width and you have a parameter constructor of rectangle class. This is a rectangle class. And then you have a display method whereby you are actually trying to display the height and width. Yeah. Now what happens, I create actually a label rectangle child by saying class label rectangle extends rectangle. Extends means you are creating a subclass of rectangle. Label rectangle is a subclass, and then you have a private property label, and you have a parameter constructor. But you understand that you are actually having three. Height, width is the property of rectangle, and str is the string, which is the property of the label rectangle. So super width and height, you call the constructor of the rectangle class and pass width and height there. That is actually the first line, and this is by saying super, you're calling the constructor of the super class. And then you write a display method. This display is an overridden method. You are actually overriding the display method of the rectangle class. So I go back again to show you something here, that when you write the display method and you are actually displaying your output here, it's fine. So this is a display method of the over class, and now look at the application class. We are actually creating a rectangle object. Then we create a rectangle, label rectangle reference. And label rectangle is a rectangle, so I can actually assign another rectangle, label rectangle here, and then call the display method. So display method is displaying two different output, yeah, because one you're calling the display of the rectangle, another you're calling the display of the label rectangle. Alright, so you can understand this very clearly, there's two display methods. So observe the body of the display method in the label rectangle class. What you're doing here, we actually have the same code, but it's actually using the get width and the set width method. So we basically replace this part by using super, that I'm going to show you. So this display method, we are actually overriding the method of the super class. So is it possible to call the overridden display method in the rectangle class? That's the question, because this is the same code as my rectangle super class. So what I can do, we can do something like this. We can call the overridden method by calling super keyword again. How? You can see here, label rectangle, this is a child class. I have this private property, and then this is a constructor. In the constructor, I am calling the constructor of the super class and passing width and height to the rectangle. And this is my local, this is my label class property. And in the display method, what I'm doing is I'm just writing this and then super.display. Super.display means I'm calling the display method of the super class. So I can have two types of super. One is super dot, another is super constructor, parameter constructor. So execute the overridden method. I call the super class. Access control is something very, very important. Access control actually controls the access of the instance variable. Determine the area of the program code which could be accessed. In instance method, there are two things. Instance method and instance variable is related to the object. Instance variable, where your program code can access the variable with reference to the object, and determine the area of program code which message can be sent to the instance of that class means using object. And there are three access control here: private, protected, and public. You're already familiar with private because you declare something private you cannot access from outside. Protected is like private, but it is accessible by the child, and public means it can be accessed by everybody. So you take a look at here. Consider the following program. You have a private integer, that's a private member, and the private member you can access from within the class, it's fine. And this is also private, you can call from within the class, it's okay, yeah. But you can see here, private access control, when you say like this, you can understand this is a public method, mint. Its main method is a public method. You're trying to access the data member ringgit. You see ringgit is a private member, but you're trying to access this ringgit from the main, but with reference to the object, but object cannot access any private, so it's an error. You cannot actually call any private property or method. So private attributes defined in the class can only be accessed within that class, yeah. And private method also can be called from within that class, but not from the main or from any other method. So now consider the following program. You made it public. At yak means, yeah, everyone can access. It has no point of encapsulation. Yeah, and it's okay also. Yeah, take a look. Yeah, it's okay because you can access the public property and public. But if the property is public, you lost your data protection. Yeah, don't make it. Don't make any property public. Yeah. So public attributes defined in the class can be accessed within that class as well as outside. Object attribute should not be declared as public. You see, understand that. Should not be declared. They should be hidden. They should be declared as private. And public method is a must. Why? Because you can call from outside to work with the data member. Protected access control, it actually As you know, it is like private, but it can be accessible in the child, the class itself, and all of its subclass. That means all the child can access those property or behavior. All of the classes in the same package of the class. I will discuss about package separately. Package will be discussed later, so we discuss about it. Look at an example here. We have a base class. B class means base class. We have a protected character type variable, character type instance variable. We have, this is private, but one is protected and this is private, and we have set data, right? Okay, set data is a method of type void. We pass a parameter u, and this u will be initialized to bx. Then we create a subclass, d class, of base class, fine, private da, but you do understand that you basically have this data member bch is automatically coming in child, so you can say bch is equal to ch. You see why? Because I can write this. Why? Because bch is also with me, because I said it is protected. So this data member I can initialize directly. So learning about the concept of inheritance is mechanism that enables one class to inherit behavior and attribute of another class. You can apply knowledge of general category of more specific object. So this is actually an example of employee class. Employee, you can see employee class. It has two private member, employee number and salary, integer and double, and four public method: get employee number, return integer, get employee salary, return double, set and get. So this is the employee class diagram. And in the UML notation, when we create actually a employee with the territory, we see this is inheritance symbol of inheritance. We say employee with territory is an employee. It's automatically, it's a class diagram showing the relationship, and we say is a. That means employee with territory is a employee. And it's the rest of the code, you know how to write it. So use inheritance to create derived class. It saves time, it reduces error. There is a huge advantage of inheritance. You save time. Why? Because you already have a base class, so you create a child, and child creation is very easy. Reduce error, reduce amount of new learning required for the new class. Base class used as the basis of inheritance, called superclass or parent class. And learning about concept of inheritance, we have a derived class, inherits from the base class. Always is a case, also called subclass or child class. And extending class, what we say, we use the keyword extends to create a child. Like we achieve inheritance in Java, it is a single class I can extend. I will be discussing about multiple inheritance in another class. So public class employee territory extends employee. Inheritance one-way proposition, child inherits from parent. Subclass more specific. Instance of is a keyword by which we can check that an object is instance of which class. Yes, so this is something new. I want to give you some example here. Look at here, this code. Public class employee with territory extends employee. I have a private data member. Then I have two methods, and this is my subclass employee with territory. So that's all up to here now, and I hope we enjoy learning in coming discussion abstract class and multiple inheritance. Enjoy computing.